Welcome to the Data Science Rabbit Hole. I'm Michael, your guide to the wonderful world of data science. On this channel, we'll be diving deep into the world of data. So come along and join the fun. Let's start at the beginning and answer the age-old question, what the heck is data science? The field is constantly evolving and is so vast and so filled with jargon and buzzwords. If you ask 10 different data scientists, you'll get 11 different answers. One of the best definitions of data science I've come across is from Drew Conway's 2010 Venn diagram. He's not the only one to make a Venn diagram, but his is sort of the classic. A data scientist should have a solid foundation in statistics, be a savvy programmer, and possess some domain expertise. So what's the big deal with data science anyway? Historically, data science emerged from statistics as a more practical and applied discipline. Think of it as a split between the mathematically inclined ivory tower statisticians and the roll-up-your-sleeves applied statisticians. Let's take a trip back to 1962 when John Tukey, one of the OG statisticians, wrote a paper that rocked the stats world. Tukey wrote, "For a long time, I thought I was a statistician, interested in inferences from the particular to the general. But as I have watched mathematical statistics evolve, I have had cause to wonder and to doubt." Tukey was over the academic obsession with abstract mathematical theories. He wanted to focus on using real data to solve practical problems. He was all about analyzing real data, figuring out how to interpret that data, how to collect data, to gather data, and to use the ideas from mathematical statistics to apply them in real-world situations. That's how data science got started. It grew up from statistics and headed out into the world like a rebellious teenager. Let's take a quick sidestep back in the 60s and 70s to acknowledge the origins of the term data science. The phrase was first introduced by the Danish computer science pioneer Peter Nauer to refer to the science of managing and processing data. It's important to note that this meaning was different from what we understand as data science today. Nauer wasn't talking about analyzing data or making predictions, but rather the fundamental principles and techniques for handling data. Back to our story. Contrary to popular belief, data science didn't start in Silicon Valley. In fact, it began to emerge as a field in the early 90s in Japan, long before Mark Zuckerberg was even out of diapers. Noburo Asumi's 1995 paper, From Data Analysis to Data Science, notes how Japanese and French data analysts had been collaborating for years, culminating in a 1992 conference in France, where the term data science was used for the first time in writing in the proceedings. Of course, it wasn't in English, it was in French, and as an American, I can't pronounce it. The first appearance in print of the term data science in English was in the title of the 1996 conference of the International Federation of Classification Societies, Data Science, Classification, and Related Methods. And yes, they did omit the Oxford comma, but we won't hold it against them. Among the early proponents of data science was Chikio Hayashi, one of Japan's leading statisticians. Legend has it that Hayashi used the term data science at a talk in a previous conference and was asked during the Q&A what it meant. So for the 1996 conference proceedings, he wrote a paper titled, "What is Data Science?" defining it in 3 phases: design for data, collection of data, and analysis of data. While data science had been making progress in Japan and Europe, it wasn't until the late 90s that it started gaining traction in the US. And it wasn't exactly love at first sight between data science and the traditional statistics community. In 1997, statistician Jeff Wu tried to rebrand statistics as data science, even calling for statisticians to be called data scientists. You can see part of his presentation slide right here. Unfortunately, the idea didn't really take off. Maybe because people were too attached to their old business cards? But tensions were growing. In 2001, Leo Bremen, a Berkeley professor, wrote a paper titled Statistical Modeling: The Two Cultures, where he called out the statistics community for being too uptight and narrow-minded. He argued that statisticians were hung up on mathematical models and not focused enough on real-world problem solving. Ouch. Statisticians were committed to a traditional, highly mathematical approach that started with an underlying stochastic data model. A small but growing community, however, was taking an approach that didn't worry about how the data was generated and focused on algorithms to make predictions based on the empirical data alone. Bremen was pretty harsh for an academic paper. He wrote that the approach statisticians had been taking, quote, has led to irrelevant theory, questionable conclusions, and has kept statisticians from working on a large range of interesting current problems. Algorithmic modeling, both in theory and practice, has developed rapidly in fields outside statistics. This is just from the abstract. He went on to say, if our goal as a field is to use data to solve problems, then we need to move away from an exclusive dependence on data models and adopt a more diverse set of tools. If only Bremen had suggested a team-building retreat with trust falls and group exercises, things might have gone differently. Also in 2001, Bill Cleveland, a statistician at Bell Labs, published Data Science, an Action Plan for Expanding the Technical Areas of the Field of Statistics. Cleveland proposed that the field of statistics needed to change substantially to keep pace with the explosion of data being generated by modern society, and that this new expanded field would be called data science. Cleveland believed that the focus of data science should be on tools applied to real-world data to get practical solutions, not abstract theories. Abstract theories are of indirect benefit, but tools, software, databases, algorithms are of direct benefit. In other words, Cleveland believed that data science should be a practical, results-oriented field that uses a variety of tools to extract insights from data and solve real-world problems. Data science underwent a remarkable transformation over time. Originally, it emerged from a split in the statistics community between the mathematically inclined theoreticians and those who were more interested in analyzing real-world data. But as the field matured, it shifted towards a tool-based focus on databases, software, and algorithms. Take the example of Tin Kam Ho, who published her groundbreaking paper on random decision forests in 1995. Despite being a computer scientist, she led a department at Bell Labs that was still called Statistics and Learning Research. But as data volumes exploded in the 2000s, maintaining massive databases across multiple servers became a daunting task, requiring computer science and engineering expertise. The emphasis on tools would be crucial for the field's development. So far, we've talked about this supposedly practical field growing mostly in academia. There was the Data Science Journal that launched in 2002, and then the Journal of Data Science that launched in 2003, because apparently when you love something, you name it twice. But the real fun started when data science began to seep into the private sector. Google's paper on the Google File System in 2003 kicked off a flurry of activity in the data world. And it was good timing too, because the amount of data in the world was growing faster than a college student's laundry pile. Programming languages like Python were around for a while, but it wasn't until the early 2000s that Python started making strides in the data science world. And let's face it, free and scalable are the most attractive words in any industry. But what really put data science on the map was the Netflix challenge in 2006. They threw $1 million out there for anyone who could come up with a better recommendation algorithm than they had. That's right, $1 million. Suddenly people were saying data science like it was going out of style, which it wasn't. In 2010, the ImageNet challenge further solidified data science's place as a major player. By the late 2000s, data scientist was a legit job title, and not just at big tech companies, at any company where they wanted to make sense out of their data. But the computer science community was now taking the lead rather than statisticians. These days, data science is heavily influenced by the computer science community, especially machine learning experts, more so than statisticians. But to be a good data scientist, you need to have a solid understanding of both fields. After all, statistics provides the foundation for data science, while computer science offers the tools and algorithms needed to analyze and make sense of large data sets. One challenge facing data science training is that many programs, such as boot camps, prioritize practical skills over theoretical knowledge. While this can be helpful for getting quick results, it may not provide a strong foundation for understanding the underlying principles of data science. At the university level, computer science departments often take the lead in data science training, which can be a positive thing as computer science provides a solid foundation for working with large data sets and implementing machine learning algorithms. However, it's important for data scientists also to have a good understanding of statistics and domain knowledge in order to effectively analyze and interpret data. As data science arose from statistics, there's been a lot of confusion as to how data science and statistics differ. Statisticians, in particular, have been taken aback by the rise of data science. A lot of statisticians have had trouble understanding why data scientist isn't just statistician by another name. In 2013, the president of the American Statistical Association at the time, Marie Davidian, wrote a column in Amstat News titled, "Aren't We Data Science?" A response column by Randy Bartlett a few months later was, "We are data science." Even the president of the Institute of Mathematical Statistics, Ben Yu, called for statisticians to, quote, own data science in a 2014 address, using the phrase, compute or concede. To some extent, statisticians conceded. Despite the fact that data science relies heavily on statistical theory and uses a lot of tools that statisticians have had for a long time, data science isn't the same as statistics. That said, data science also isn't the same as machine learning or Python programming. Data science encompasses a large number of activities, including data engineering, data analysis, modeling. Right now, the computer science community tends to be in the driver's seat. But there's still a lot for the statistical community to contribute to data science, not to mention other domains like business schools or the sciences. Domain knowledge is an essential part of data science. In other words, it takes a village to raise a data scientist. Of course, this is just one perspective, and I'm sure there are many more out there. So if you have any thoughts or comments, feel free to drop them down below. And if you found this video helpful, don't forget to like and subscribe. And if you're feeling adventurous, you can hit that bell button to be notified when we post another video. You can also find the Data Science Rabbit Hole on TikTok, Instagram, Twitter, Mastodon. That's all for today's spelunking adventure into the depths of data science. I'll see you when I see you.